All right, 9.1. I already typed out the notes. One, because I understand my handwriting is not always the best, making your notes on the iPad through the video. So I already went ahead and typed out part of your notes. And I'll just highlight where we're going to be talking about and such. All right, so attributes of quadratics from graphs. Some examples on the left side of a quadratic graph is, as I mentioned to y'all yesterday, that anything with an exponent of 2 or the highest exponent of 2 is going to be a quadratic graph. Anything with not an exponent of 2, rather is one exponent of 1, no exponents, or exponent of 3 is not considered quadratic graph. Quadratic functions have U-shaped type of graphs that are called parabolas that can open up or down. The domain of a quadratic function is the set of all input values. These are also known as independent or x values over which the function is defined. These should always be all real numbers. I put ARN for short. The range is a set of all output values. These are also called dependent and y values of a relation or a function. A quadratic parent function is y equals x squared, or f of x equals x squared. The only thing difference between those two was the one had a y, one has f of x. It has a domain of all real this graph has a domain of all real numbers, and the range of y is greater than or equal to 0. So if you look in that graph on the left side, that is my y equals x squared, or f of x equals x squared. My domain is all real numbers, and all the values of y is going to be at 0 and going above it according to that graph. It will not go below that 0. This can be read as all real numbers greater than or equal to 0 as well. We're going to also label the function's minimum value, which and the axis symmetry of the graph. My minimum value is going to be 0, 0. That's basically the vertex of the graph. And my axis symmetry is always going to be x value of the graph. In our example 1, it asks us to circle all the that represents a quadratic function. We have negative 7x to the third power minus 4. I know that's not a quadratic function because the value of the highest exponent is 3. So that's not going to be a quadratic function. The next equation is f of n equals 2n squared plus 6n minus 7. The highest exponent was 2, or the highest degree was 2. So that's going to be a quadratic function. The next equation, h of t equals 12t plus 14. First, the variables are different, but it doesn't really matter. It would still should make a graph. In this case, it makes a linear graph, so that's not going to work. And the last equation, y equals 25 minus 3x squared. Highest exponent 2 is not currently written in standard form, but still the highest exponent is 2. So that would be a quadratic graph. Quadratic graphs makes U-shape, even when it's upside down. So this was a U-shape upside down, and this is a U-shaped type of graph on the very right side. Now we're going to look at the anatomy of functions. Again, I'm going to highlight the parts that's already written out. Graphs are quadratic functions that are parabolas that open up or down. We talked about this yesterday, but the vertex of parabola is a maximum, or the graph that opens down, or the minimum, which the graph opens up. The max or minimum of a parabola is located at the vertex of the graph. For every single max or min, there's going to be located at the vertex. The axis symmetry is the vertical line that passes through the vertex, or the x value if you want to put that somewhere on your side notes. To determine the direction of opening a parabola by looking at the value of a, written in standard or vertex form, if the quadratic's coefficient is positive, the parabola opens up. If the a is negative, the parabola opens down. We haven't talked much about this, but the y-intercept is where the parabola intersects the y-axis. We've been talking a lot about x-intercepts, but now we're getting into y-intercept in this chapter. We have a couple examples talking about our graph on the left side. All right, so we have this graph on the left side. My vertex is going to be this point right here, or my maximum. Okay, so that point is x value -2. And y value being 1, 2, 3, 4, +4. This has a maximum, okay? Reason why is the highest point. The minimum is way down below. You see arrows going downwards. So this would be a maximum. I'm gonna put max for short. The axis symmetry is a line that goes right through the middle, and the axis symmetry will be x equals -2. My y-intercept is going to be located right here, so it'll be y equals, and I can just find out what the y value of that point where across the y-axis. 2, 3, 4, be y equals -4. Direction of opening is opening downwards. It's not facing up, so this would be facing downward type of graph. My domain's always going to be all real numbers. And my range is going to be y is less than or equal to +4. Reason why? Because all the y values of this graph is going below 4. Our next graph here, to determine a vertex, I'm going to find where the graph makes its turning point. So you're going to put a blue dot there. That's where the graph's making its turning point. Right there. So that x value is 1, 2, 3, +3. And -1. This graph has a minimum. The max, if you notice, there is an arrow going upwards. It doesn't stop forever. So this is going to be a minimum. My axis symmetry is the x value of the vertex, so it'll be x equals 3. My y-intercept is where across the y-axis. It's going to be right there. It crosses at y equals 2. I'm going to make a better y for y'all. Direction of opening is up. And a domain is going to be, I'm going to use interval notation for this one example. It'd be -infinity to +infinity. And the range can be from going from the bottom to the top of the graph. So my bottom is the -1. And going to the top, which is +infinity.